I know you're thinking, Dr. P, can I just get all of the shapes and all of the graphs and you tell me when something is speeding up and when it is slowing down? Yes, I will tell you that. The first shapes that you would be concerned with are straight lines, and we've already talked about that. These things, like this red line, is an object that's moving with constant speed in the positive direction. So remember, the slope of this line becomes the slope of this line, constant speed in the positive direction. The red goes with the red. Constant speed means no acceleration. What happens if this guy is traveling faster? Like this, a bigger slope means a faster velocity, so the green line would go with the green line, but still no acceleration because this is a constant slope. What happens if he's traveling slow in the negative direction? Well, absolutely. The velocity will be small and negative, so it'll go down here. Again, the acceleration is 0. So that's all the stuff that was covered on the first test. What do you actually get then for curved lines? So the most prevalent curved line I think that you've seen probably is an object that starts like this and evens out like that. So this is an object that starts off fast. Their speed decreases over time. This would be like you in your car driving down the road at some speed, and then when you see the stop sign or the stoplight, you press on the brake. This is when you start the time, is when you press on the brake and you slow down and you stop over time. Your velocity starts off big and positive and then becomes negative. The slope of this line is your acceleration, which will also be negative. If you had the same idea of an object that was slowing down to a stop, but traveling in the opposite direction, so starting off over here and traveling this way, this object position versus time graph would look like this. He's starting off with a big negative slope, and that big negative slope is trending towards 0 over time. So a big negative slope, big negative velocity, trending towards 0 over time. And I don't know, maybe looks something like this. Now this slope is the acceleration again, but this slope is positive. So I'm going to put a positive up here. Now both of these graphs are for objects that are slowing down. It's sort of weird that even though both of these graphs show an object that's slowing down, one has a positive acceleration and one has a negative acceleration. And so slowing down does not necessarily mean negative acceleration. It just means that your velocity is decreasing. And so you can decrease to 0 here or decrease to 0 here. Really, if you look at the sign of velocity, here the sign of velocity is positive. Here your sign of your velocity is negative. If you look at the sign of the velocity, positive and negative, negative here, and the sign of the acceleration, if these signs, velocity and acceleration, are opposite, that object is going to slow down. Opposite. Opposite signs mean slowing down. Okay. So we could have a graph that starts off slow and gets faster. So this object starts off slow, close to 0 velocity, and becomes faster over time and is moving in the positive direction. Here we go, positive direction. So we have a positive slope here, which will give us a positive acceleration. The sign of the velocity here is positive. The acceleration is positive. Same signs for velocity and acceleration means that this object is speeding up. So just like we said here, this is speeding up. Now we can have the same idea of an object that is speeding up in the negative direction. Shoop. That wasn't super great, but the velocity starts off 0 and then becomes bigger in the negative direction over time. This acceleration is negative because the slope of this line is negative, so we get a negative acceleration here. Oop. We get a negative acceleration here, and this sign of the velocity, all of these velocities are in the negative direction. They're all going downward, all traveling downward. And so again, we see same signs speeding up. This green line here represents an object that would be dropped. Because the acceleration due to gravity is constant and negative, it's always pulling things downward. We get this constant negative acceleration where the velocity increases in the negative direction. So if you're ever asked to graph the position versus time graph of something that's dropped, it will look like this. The velocity versus time graph for that will be this green one. And then the acceleration is here, where this would be at negative 10 meters per second squared. So what would this graph of an object that's thrown in the air and caught at the same height, what would that look like? Well, if I throw something up in the air, it starts off with a big positive velocity. That velocity decreases over time, and then the object will turn back around and travel in the negative direction. So the velocity starts off positive, becomes 0, and keeps traveling in that negative direction. So this is the velocity versus time graph for an object that's thrown up in the air and caught. While your acceleration versus time graph, again, the slope here does not change for this whole time, so this slope is going to be negative and constant. Couple of fun facts for things that are thrown in the air. The amount of time that it takes to go up, let's call that t, is the same amount of time that it takes to go down. Let's call that t total, and maybe we call this t1/2. Same up, same down. The velocity with which you throw something up in the air is going to be the same velocity with which you catch it. So this velocity, if this is v, then down here is going to be v negative, where the area here and the area here are going to be the same because the area is the displacement. So you have a negative displacement while it's traveling downward, and you have a positive displacement while it's traveling upwards.